Okay, video number 2 on dividing fractions. So, we're actually not going to divide anything. We're going to keep this fraction the same. So it's still going to be 2/3. We're going to change it into multiplication, and then we're going to flip this second number. So it's going to be 5/4 equals. So then we just multiply straight across because that's how you multiply fractions. So it's going to be 10/12, and you're done. Well, it's going to obviously be simplified. They're both even, so I can cut them in half. And that's your final answer. What about this scenario here? So here you're going to multiply 1 times 5 and then add 3 because you have to turn it into a fraction before you start. So 1 times 5 plus 3 is 8. That's our new numerator. And then we're going to turn that, well, first we're going to keep it as division right now because we're just turning everything into a fraction. How do you turn a 7 into a fraction? You put a 1 underneath it. Now you can do keep, change, and flip. And you get 8/35. They have nothing in common, so you're done. Here, you're going to do the same thing. A little bit higher. There we go. Here, you're going to do the same thing. You're going to make this into a fraction. So 2 times 3 is 6 plus 2. That's going to be 8. So it's going to be 8 is your new numerator. Then you are going to change this. Well, not yet because we're still changing everything. It's going to be 1 times 5 plus 1. That's going to be 6/5. And now that that's done, you're going to do keep, change, and flip. And now you just multiply straight across here. 8 times 5 is 40, and 3 times 6 is 18. This is improper. You can use the clock. So it's going to be 40 divided by 18. It's improper because the top number is bigger than the bottom. That's the only time you do this division here. So then you do how many 18s fit in here? That's going to be 2. 2 times 18 is 36. Then you're going to subtract and you're going to get 4. So the answer is 2 and 4/18. So 2. See how I scroll this up a little bit. 2 and 4/18 is going to be your solution here. So it's going to be simplify the 4/18, and you're going to get, because you can cut them in half, so it's going to be 2 and 2/9. There's your final answer, but these are all correct answers. Don't get me wrong, they are correct answers, but the one I want is this is the final one here, is the best answer. Okay, so now we're talking about turning repeated decimals into fractions. These two are going to be pretty simple. This, okay, 2 is repeating forever. That's what this little line up here means. 2 is going to be repeating forever and ever and ever. So it's going to be 2/9. Okay, this 21 is repeating forever. 21 forever, forever. 21, 21, 21, 21, forever, forever. So how do I turn this into, you put 21/99 because there are 2 numbers repeating. Okay, now these two are different because not every single number behind the decimal point is repeating. You see on this one, the 21 is repeating forever. This one here, the 2 is repeating forever. Everything behind the dot is repeating. Here it is not. The 3 is not repeating. It's 0.31 forever. So how do we do that? So I will show you right now. We're going to break it down. So first you make it equal. So we're going to make this equal to x. Okay, so equal to x. Okay? And then we're going to multiply both sides by 10. Why 10? Because one number is repeating forever. If there were 2 numbers repeating forever, I would have multiplied by 100. But this one, we're just going to multiply by 10. So we're going to end up with 10x on this side because you multiplied it by 10. And this side, we're going to end up with 3.1. And 1 is still going forever, but it's just going to be 3.1. Okay? Looks like a T, but that's a 1 with a line on it. Second step, so that's the first step. Second step is we're going to put this underneath it and subtract it. So this x goes down here, and we're going to write minus x. And 0.31 forever is going to go here. So 0.31 forever is going to go here. And we're also going to subtract. Now what goes here? You're thinking 0 because you're used to filling in every gap with a 0. But in this one, 1 is repeating forever, so actually a 1 is here, and it's also repeating forever. So the 1 is repeating forever. So let's subtract this side first. 10x minus x, that leaves us with 9x. This one now, the forever one minus the forever one is just going to be gone. It's going to make nothing. It's going to make infinite zeros. So we can ignore that for now. Now there's going to be 1, so I'm going to borrow from here, make it 11. 11 minus 3 is 8. Drop down the decimal point. 2 minus 0 is 2. So it's going to be 2.8 equals 9x. Now we're trying to leave x by itself, so we're going to divide by 9. That's my division. Divide by 9, and now we have our new fraction. But fractions can't have decimal points in it. So if we move this decimal point over here, right? Now it's just 28. But whatever you do to one side, you have to do to the other. So we're going to leave a blank spot, so it's going to make it 90. And that's it. It's all done. Now, they're even, so they can be simplified. So that's going to make 14 over 45. And there you go. Okay, now let's do this other one. 10.271, and 71 is repeating forever. Now the 10, I know the answer is going to be 10 point something. So 10 in a fraction is just going to be 10, and then here's the fraction that goes there. So I'm just waiting to put the fraction there. All the way down here. Okay, so now we're going to go back up here so you can see it, and then we're going to work on it, okay? So now I've already ignored this, so we're going to ignore that for now. I'm just looking at the 0.271. So 0.271, and the 71's repeating forever. I'm going to make it equal to x. This time I'm going to multiply by 100 because the 71 is repeating forever. So this is 100x equals, move this over twice, and I get 27.1, right? And remember, the 1 is repeating forever, and so is the 7. So we're going to have it like that, 1, 7 forever. Now I'm going to move this down here. So minus x, and that gives me 99x. Here it's going to be minus 0.271 forever. Now remember, the 71 is still going on forever over here. So 7171 forever. So this cancels out, and I'm left with this. I'm going to get a 6 here. This is going to be a 9. The decimal point goes here. 6 minus 0 is 6. 2 minus nothing is 2. So now we have 99x equals 26.9. We're going to move them both to the other side. So x equals, so divide by 99, divide by 99. Now we're done. X equals 26.9 over 99. But again, I don't like decimal points in my fractions, so we're going to move this a little bit more, and we're going to be left with x equals 269 over 990, because I moved this decimal point over, and I moved this decimal point over. Okay? This divisible by 269. That is not divisible by 3 or 9. So this one's divisible by 9 and 3 and 2, and this one's not. Okay, so we're done. So there's our final answer. 269 divided by 990. That's the most complex one. Okay, I want you to realize that all these other things were pretty easy. All right, so our next thing we're going to talk about is rational and irrational numbers. So let's go here. Okay, so rational numbers, the pure definition is a number that can be made into a fraction. Okay? Now, if you don't know what a square root is, or a radical, it's asking you what number times itself equals the number inside. So this actually has an answer. It's 4. So this is considered to be a rational number. Okay? 4 can be made into a fraction. 3 is irrational because there are no two numbers that exist that multiply together that make 3 that are the same number, because 1 is too little, 2 is too big. So now you're going to find a decimal point, and there's no decimal point times itself that makes a whole number. So it's going to be a repeating, not a repeating decimal, a decimal that goes on forever and also never repeats. So this makes this number irrational. Okay, I can never actually show somebody the entire number here. They'll never know what it looks like. Okay? Same thing with pi. Pi is an irrational number. Okay? It goes on forever and never repeats. This is a fraction. The definition of a rational number is a number that can be made into a fraction. So this is rational because it can totally be made into a fraction because it is a fraction. This number, 7.25418, and now you can notice that there's no repeating. So this probably goes on forever and never repeats, which means we're assuming, because we don't know what the rest of the dots look like, that this is irrational. Okay? This one is rational because it's 3.252525. It's a repeating 25. And I proved in the last section that you can totally make this into a fraction. So this is rational. Okay, and the number here, 9, that's a whole number, so that's also rational. Now, I already told you the book definition, but my definition is if you cannot describe this number in its entirety to somebody else, then it is irrational. Can you explain the square root of 16? Yeah, it's 4. It's a whole number. So yeah, this is 4. What about this number? Oh, well, if I had to show you this whole number, I would be talking for my whole life. So it's irrational. Same thing with pi. It never repeats. So then you'd be talking forever. This is a fraction. So I would just say 1/5. There you go. All done. This one, 7.25418, it keeps on going, but doesn't repeat. So it has to be irrational because I'd be talking my whole life to get somebody to understand this. This one is rational. Look, it goes on forever, but I could just say it's 3.25 and then 25 repeats forever. Boom. You know exactly what that looks like. And then obviously 9 is a rational number because it's a whole number. And that's the whole lesson.